Hi guys. In section 8.2 we're going to talk about trigonometric ratios, and we call these trig ratios for short. So we've talked a lot about ratios, but this time we're going to talk about specific ratios, and these have to be in right triangles. So all right triangles with congruent angles are similar. So if we take a look at these triangles here, they all have a right angle and they all have an angle with 53 degrees. So by angle, these triangles are all similar. Now what that means is they have the same shape, but they're not necessarily the same size. And what do we know about corresponding sides? Well, the ratios are the same. So if we wanted to test this, we could take like the hypotenuse and divide it by the short leg. So over here it's 8 over 4.8. Here the hypotenuse is 5 and divided by the short leg, which is 3. And this one, the hypotenuse is 7.5 divided by the short leg, which is 4.5. And if you type all of these into your calculator, you're going to get the same decimal out. You're going to get 1.6 repeating forever and ever. So because these are all similar, we know we can make ratios, and their ratios will eventually equal each other. So how does that help us? A trig ratio is a ratio of two specific sides of a right triangle. We're going to use this symbol a lot. The symbol is called theta. The three important sides that we're going to talk about are the hypotenuse, the opposite, and the adjacent. So in a right triangle, your hypotenuse, remember, is always across from the right angle. Now the opposite side depends on what angle we're talking about in here. So theta is what we use instead of x to represent an angle. So this up here is an unknown angle. So let's say this is the angle that I don't know. The opposite side would be on, guess what, the opposite side of the triangle. So across from theta. And my adjacent side is right next to theta, so this would be my adjacent. So next to the angle. Now, if I was talking about this angle down here, let's say this guy was theta, the hypotenuse is always the same, but this time my opposite side would be over here, and my adjacent side would be right here. So that leads us to some definitions. We have three words that you're going to put in your vocab that you will say from now until eternity: sine, cosine, and tangent. Now these are special ratios in a right triangle. The sine is your opposite leg divided by your hypotenuse. Your cosine is the adjacent leg divided by the hypotenuse. And finally, your tangent is the opposite divided by adjacent. Now, that's a lot to remember. So, mathematicians have come up with something that will also stick in your head. SOHCAHTOA. So the SO stands for sine, right here, sine, S-I-N, of an angle is the opposite over the hypotenuse. Cosine, cosine of an angle is adjacent over hypotenuse. And then finally, tangent, the TOA part, so tangent of an angle is opposite over adjacent. So you're going to get problems like this, where I give you this triangle, LMN, and we need to find the sine, cosine, and tangent of certain angles. So let's find the sine of M. So this is the angle we're talking about. This is our theta for right now. And if this is our theta, then we have our hypotenuse. Remember, this never changes. Our opposite side would be over here, and our adjacent would be the one right next to it. So sine, the so part, means that we're going to take our opposite and divide it by the hypotenuse. So our opposite side is 8, divided by the hypotenuse, which is 10. The sine of angle M is 4/5. So that just means the ratio of the opposite and the hypotenuse for whatever that angle is 4 divided by 5. Let's keep going with angle M. So let's jump down here to tangent of angle M. So everything still looks the same, except tangent is the TOA part, which is opposite divided by adjacent. So our opposite side is still 8. Our adjacent side is 6. And we're just going to simplify this. So remember, it's a ratio, so leave it as 4/3. Don't turn it into a decimal. Last one, cosine of angle M. Remember, this is the ca part. So that means we're going to take our adjacent divided by our hypotenuse. Adjacent 6, hypotenuse is 10. We end up with 3/5. So now things change a little bit when we talk about this same triangle, but we're talking about angle L. So angle L is now going to be our theta. And if that happens, then our hypotenuse stayed the same, but this time this guy over here is our opposite side. And this guy right here is our adjacent. So when I need to find the cosine, that's our ca, I'm going to take the adjacent divided by the hypotenuse. This time my adjacent is the one right next to it, so it's 8. And my hypotenuse is still 10. So this simplifies to 4/5. And then the last one, the sine of L. So this is the so part. Opposite divided by hypotenuse. The opposite this time is 6. And my hypotenuse is still 10. So we end up with 3/5. We're going to skip this next part until tomorrow, and I will do it with you. So move on down to this. Using your calculator, find each trig ratio, round to the nearest hundredth. This is literally making sure that you can type this stuff into your calculator. You can do this on your phone, or you can do it on an actual calculator. On an actual calculator, there are the 3 buttons right above the numbers. On your phone, you're going to have to turn it sideways, and you're looking for SIN, COS, TAN. So if you're using a calculator, you need to type in this operation, and it automatically puts up a parenthesis. Type in 52, close your parenthesis, and hit enter. Now if you do it on your phone, you kind of got to do it backwards. So for this, you got to type in 52 and then type in the sign, the SIN, and it's right across from like the 1, 2, 3 if you go all the way across, and then it's just going to spit out a number. That number is your answer. So 0.987 is what I got for this one. Do the same thing for all of these and make sure that you can get the same numbers that I'm getting in your calculators. So negative 1.47 is what I got for that one. If you're not getting these numbers in your calculators, reset your calculator or wait until tomorrow and you can ask me. So we're going to save this part until tomorrow as well. So you have 2 IXLs that you can work on. You have the worksheet that is due before you leave. And then you have the worksheet from yesterday. So this is the 8.2 worksheet that's due before you leave, but then you also have that geometric mean worksheet from yesterday that you can work on. So make sure you're using your time wisely. Make sure you write down any questions you have, and we can go over them together in class. Enjoy your night.